Good morning, boys and girls. I hope you all are doing your test well. Okay, your physics test is on 30th of this month, so we have almost a week, more than a week, in fact. So let us continue with our syllabus. Okay, otherwise we'll be lagging behind. So your syllabus for test is complete, and I've sent some revision questions also. So do them, okay? And I'll, I think I'll send a few more questions also, okay? But still we have a lot of time, so we'll continue. And now we are on chapter 3, so we'll start it, okay? Just uh, go through it, okay? Uh, the introduction of this chapter we'll do today. Okay, so the chapter is about energy. Okay, third chapter is about energy. And what is energy? In fact, energy is okay. Energy. uh, Look at the definition given in the book. It's the capacity for doing work. Okay, so we'll follow the big book only. So energy is the capacity for doing work. Now, if you do any work, energy is required. Okay, for doing work, energy is required. And if you apply some force on a body and it moves, then work is done. Okay, if the body moves by applying some force, it moves, then work is done. That is called work. Okay, and for doing work, energy is required. So these terms are related. Okay, force, work, and energy. They are related with each other. Okay, now uh, here energy are also of different types, so we'll come to it later. So mainly two types, kinetic and potential. Kinetic energy is the energy which a moving body possesses. Okay, a moving body is having some energy because of the motion, and that energy is called kinetic energy. And if energy is because of the position of a body, then it's called potential energy. So energy because of its position. Okay. So when okay, with examples it will be clear. So okay, now here okay, come to the book itself. Okay, example we will take from here. Okay, when you must have seen dams. If you have not seen, okay, whenever you get a chance, okay, visit a dam. Okay, so in dams, what happens? Water is stored. Okay, it is blocked. Water is blocked, and when it is blocked, a river, in fact, in rivers, water is blocked. So when on a river, water is blocked, it attains height. Okay, dams are very high. So when water levels rises and it goes higher and higher, so it pauses because of the height. There is potential energy in that water. Okay, and by the use of that energy, electricity is produced. Okay, in hydroelectric power stations, this is how electricity is produced. Okay, so when water is blocked over there, so there is a passage made to move the water. Okay, they leave the water from there, and it passes with a very high pressure. Okay, because of the height, and now it has, because it's moving, the water is moving, so it has now kinetic energy, and there is a turbine put over there. Okay, because the water has the kinetic energy, the turbine is rotated. Okay, what is a turbine? We will not go into the detail. Okay, turbine is a device which converts uh, okay, the kinetic energy into electrical energy. Okay, it rotates, and mm, we'll study it later. The electricity is produced because of the machine. Okay, it's a big machine. So by using this kinetic energy, the electricity is produced. Okay, it is converted. In fact, it is converted into electrical energy. So here the two types of conversion are here. First of all, the water has kinetic energy because it's flowing in the water. Then it is blocked and stored. It attains some height. So that is converted into potential energy. And again the water is released. So it has kinetic energy. And again this kinetic energy is changed into electrical energy. So these are the conversions of energy. And energy can be converted only. Okay, it is neither created and nor destroyed. It can be converted only. Okay, it is converted only. It is not created and not cannot be destroyed also. Okay, this is called, here it's given in the book also. It's called the law of conservation of energy. Okay, here the last line here on this page. Here it is. Okay, so energy is only converted. Uh, if we want to use energy, we store it in some form and then we use it. Okay, this is how we are using energy. Okay, now, okay, work. What is work? When we apply some force and there is movement in the direction of the force, then that is called work. Okay, so there should be a force and there should be movement in the direction of the force. So if these two factors are there, then work is done and energy is required, for doing work. And okay, so these energy and work are related. Now, to do work, energy is required. Okay, and okay, for work there is a formula also. Work is equal to, here it is, force into distance. This is distance here. S is distance here. So if you want to calculate work, we can calculate using this formula. Okay, we will multiply the force and the distance moved by the body force applied upon the body, and the distance moved by the body. When we multiply this together, we get the amount of work done. Okay, okay, we'll not do much today, okay, because you are studying for your test. So this is just introduction of the chapter. So at least you give some time, okay, to go through this chapter. Okay, to go through at least this page and this page. Okay, just look at it, what is given in this chapter, and in the next video we'll continue, and we'll continue from the same topic. Okay, work and energy and work, or work and energy. So just give some time to this 2 pages and just read it, and we'll do it in the next class. Okay then.